So, today we're going to tackle a topic that sounds super complicated, adding and subtracting complex numbers. But here's a little secret for you. If you've done any basic algebra, you've pretty much already got this down. Let's break it down and you'll see what I mean.
All right, just take a look at this. On the left, you've got a totally normal algebra problem with an x. You know exactly what to do, right? Combine the x terms, combine the numbers. Simple. Now, look at the problem on the right. Yeah, it looks a little weird with that I in there, but the way you solve it, it's exactly the same. That's the whole key right there.
At its heart, this is all about combining like terms. Seriously, it's a skill you've been using for years. We're just giving it a new coat of paint.
Here is the absolute main idea, the big trick. When you're adding and subtracting these things, just pretend that I is any old variable, like x. That's it. Don't let the word imaginary throw you off. Just focus on grouping together the stuff that looks alike.
Okay, so let's get the official rules of the game down. Don't worry, there are only two, and they are incredibly straightforward.
So for addition, it's exactly what you'd think. You just grab the real parts, the a and the c, and add them up. Then you grab the imaginary parts, the b and the d, and add them up. Real with real, imaginary with imaginary. That's literally it.
Now with subtraction, whoa, hold on. There's one tiny extra step, but man is it important. This is where almost everyone messes up. Before you do anything else, you have to take that negative sign and distribute it to both parts of the second number. Forgetting to hit that second term is, without a doubt, the #1 mistake people make.
Okay, enough talk. Theory's one thing, but let's actually get our hands dirty and see how this works in practice. We'll walk through a few examples, starting with a nice, easy addition problem. Okay, here we go. Example 1. As you can see, first thing we do is group up the real numbers. That's the 3 and the 2. Then we group the imaginary parts, the 4i and the -6i. Now we just do the math. 3 plus 2 is 5. 4i minus 6i is -2i. So our final answer is 5 minus 2i. See? Not so bad, right?
All right, subtraction time. And what's rule number 1 with subtraction? You got it. We have to distribute that negative. So that 7 plus 3i becomes -7, -3i. Once you've done that, it's just a simple cleanup job. For the real parts, 5 minus 7 gives us -2. For the imaginary parts, -2i minus another 3i gets us -5i. And there it is, our final answer, -2 minus 5i.
And what's cool is, this works even if you throw a bunch more terms into the mix. The rules don't change. First things first, we see that subtraction sign, so we distribute the negative to the 4 minus 2i, which turns it into -4 plus 2i. Then it's just a big collecting game. We gather all the real numbers, 3 minus 4 plus 6, that gives us 5. And then all the imaginary ones, I plus 2i plus 5i, that's 8i. Put it all together, and we get 5 plus 8i.
Now, this all seems pretty straightforward, right? But there are a couple of classic tripwires that are just so easy to stumble over. Let's put a spotlight on them so you can sidestep them completely.
If you were a teacher grading a pop quiz on this stuff, where would you expect to see the most red ink? What's the mistake that just keeps popping up again and again?
Well, it pretty much always comes down to two things. First, and this is the big one, people forget to distribute that negative sign all the way through to the second term. And second, your brain sees those parentheses and just screams, FOIL or multiply. You have to fight that urge and look at the sign between the parentheses. If it's a plus or a minus, all you're doing is combining like terms.
Look, if you take only one thing away today, let it be this. That negative sign in front of a parentheses applies to everything inside it. It's a package deal. You're not just subtracting the first piece, you're subtracting the entire complex number.
And here is where that rule really shows up. If you're subtracting a term that's already negative, like in this example with -2i, those two negatives cancel each other out and become a positive. It's paying attention to these little details with the signs that can make or break your answer.
Okay, I know what some of you might be thinking. Cool math trick, but am I ever actually going to use this in the real world? And you might be surprised, but the answer is a huge yes, especially if you get into fields like physics or electrical engineering.
Yeah, a great way to think about it is like a map. The real part tells you how many steps to take east or west. The imaginary part tells you how many steps north or south. So if you make a bunch of different movements, how do you figure out where you finally ended up? Well, you just add up all your east-west moves and then add up all your north-south moves.
Engineers use this exact same idea to figure out the total effect of a bunch of competing forces on a bridge or different electrical signals in a circuit.
So, you've totally got addition and subtraction down now. That's awesome. But it kind of begs the question, right? What happens when you try to multiply them? Well, that's when things get really interesting and you start to see why I is so special. But hey, that's a story for the next explainer.